The effectiveness of a blood pressure drug is being investigated. An experimenter finds that, on average, the reduction in systolic blood pressure is 68.3 for a sample size of 701 and a standard deviation of 18.2. Estimate how much the drug will lower a typical patient's systolic blood pressure using a 98% confidence interval. Enter your answer as a trilinear inequality accurate to 1 decimal place. Okay. So essentially, digging through the information provided, what we want to find is a confidence interval with a 98% level of confidence. So the confidence interval, so the confidence interval for the mean effectively what we would do is take our sample mean plus or minus a margin of error. But we're not going to use formulas to come up with this. We're just going to use the calculator directly. And the calculator has 2 different functions for finding the confidence interval for a mean. It has t-interval and z-interval. T-interval is based off of t-distributions, and z-interval is based off of normal distributions. And they're both very much related to one another, but they have differences. To use the normal distribution, we would need to know the population standard deviation. But here, if you look at our data, we have a sample size of 701, so that is n equals 701. Then we have, on average, the reduction in blood pressure is 68.3, so that's the mean of our sample. And then we have a standard deviation of 18.2. And this is the standard deviation from that sample. So we don't have a population standard deviation, we just have a sample standard deviation. Which means we'll use the function t-interval in the calculator. The only thing that we have to make certain of is the central limit theorem is satisfied. And the central limit theorem is satisfied under 2 conditions. And one is that you have a large sample, which is bigger than 30. Since our sample size is 701, we have nothing to worry about. So we are good there. So we'll go over to the calculator and hit stat and then slide over to tests. Then we'll use the function t-interval. You can input from data or stats, but in this case we have the statistics and not the actual data values. So we'll just leave that checked. The sample mean is 68.3. Standard deviation is 18.2. And my sample size is 701. The level of confidence is 98%, so 0.98. And I'll hit calculate. So the endpoints of my interval then are 66.7. It said to do 1 decimal place of rounding, and 69.9. That is the confidence interval for this problem.